Welcome back, designers. We are so close to being done. We're on the 6th step out of 10. We are going to set up the brick variables and build this brick field. So let's start. Up here, we've got all these wonderful variables. Let's go all the way down and brick variables. All right, we're going to do constant brick row count equals 3. Okay, keeping it simple. Constant brick row brick column count. Oh, column. Wow. Okay. Equals 5. Okay. We're going to do constant brick width equals 75. Okay. Each one's going to be 75. Sounds good. You know, if I were doing the brick width, I mean, I am, right? But if I was doing this, I feel like I would make the brick width, like if I have the column count, I would divide the size of my canvas, right? Like this, this canvas dot width divided by 2. I would do canvas dot width divided by brick column count in order to get the actual brick width. That's just me. Maybe we'll do that because, you know, they've been in this tutorial. They have often, you know, told us, they've often had us change variables after we define them, you know, to make it a little bit easier. So maybe we'll do that. Constant brick padding, but then we wouldn't be able to have a constant, right? We'd have to change it, which is cool. That's fine. Constant brick offset top equals 30. Okay, so it's going to be like down a little bit. Constant. Oh yeah, because doesn't the ball have to bounce? Again, I would probably make that dependent upon the size of the ball. Yep. Left equals 30. Again. Because remember, like you can make the ball go on the sides and on the top. So I think it really would technically have to be dependent. Okay, so anyways, we have all this good stuff. They won't touch each other. My top and bottom. We've given some padding, right? Okay, so we're imagining this right now, right? I mean, just us naming constants doesn't do anything. We actually have to do it ourselves. So now we're holding all our bricks in a two-dimensional array, and it'll contain the brick columns C, okay, and the rows R, which in turn will contain an object including the XY positions. To each brick on the screen. Add the following just below your variables. Okay, so now we're gonna 2D array for bricks. Cool. All right, constant bricks, and look, we're equaling an array. All right, and then we're gonna fill the array. So for, let's see, when C equals 0. Okay, while C equals 0 and C is less than or starting at C equals 0. While C is less than brick column count, then we're going to do add to C, add 1 to C. Okay, open up this function, and then bricks C, so it's going to be the placement of the brick, right? The placement of the brick inside equals an empty array. Okay, two-dimensional array. Okay, cool. Okay, so we're putting the array inside the array, and then let's see. Keep it in there for, and then for let r equals 0 to start, and then r is less than brick row count r plus plus. Open up my brackets, bricks, C, R, ooh, okay. Equals an object. I don't totally understand this yet. I'm a little bit like super honest. Okay, so the code above will loop through the rows and columns and create the new bricks. Note that the brick objects will also be used. Okay, so these are the brick objects, right? The curly braces. X0, Y0. For it's going to put it in and it's going to make it equal to 0. Okay. Property X is a number, Y is a number. Our X and Y are the canvas width. Okay, let's check this out. Brick drawing logic. Okay, so we're going to create a function. We're going to draw them, and we'll just have this function up here, I believe, because we don't need to. Okay, so here we're going to have brick drawing function. So first, we're going to look through all the bricks in the array and draw them on the screen. So we're going to fill them. Our code might look like this. Okay. Okay. Draw bricks. I like that they say it might look like this because there really are a bunch of different ways to draw a function, you know, to make a function. Everybody's going to have a different route. As I grade papers, I wind up seeing a lot of stuff, seeing stuff that I haven't thought of. And sometimes people come up with stuff that I have to like figure out, like, does this work, you know, because yeah, or like they'll send me something and it's like so close to working and I've never come at it like that before, and so I have to like figure it out from their perspective, and I don't know, I like that. It's I wish it took less time, but I do really like it. One of the joys of teaching programming. Brick row count, and I'm always learning, right? Like, you know, this is the first go round with this, and I think my students are ready for it. I mean, it helps that we're doing it together. Dot X. So this, okay, this is an array, and it's calling, remember when we have two arrays, it's a 2D array. So it's calling the column and the row dot X equals 0. I'm still trying to figure that one out. Dot X equals 0. If you know what that logic is, let me know. It might not be my A game today. I don't know. Maybe I'll figure it out later, because sometimes, you know, if I just keep going, eventually I'll understand. Just keep swimming. All right, let's make this rectangle. Okay, we're starting at 0, 0, but we can remember that that's the X and Y, right? So it's the X and Y. But we're telling it the C and the R. Okay, so when it's 0, 0, dot X. X actually starts at like 2, right? Yeah, the canvas width divided by 2. Oh, so we're starting at the middle. Okay, see, starting to understand. Okay, so brick width, brick width, which is an object, and brick width is the the width, obviously. Brick height is the height. Okay, I'm gonna have the fill style. I want it equal to random color. Okay, ctx dot fill style. Meh. I'll just make it. I don't know. I don't want their color, but let's see. Equals random color. Equals the same random color. Where is it? I did it in the paddle. This is the walls. Fill style equals ball color. There it is. Let's make it the ball color. Ball color. Okay, cool. Ball color. It might not let me do that because it's above the function. Let's see. No, because we're gonna call it later. Let's see. Okay, so ball color. And then I'm gonna make it, I don't know. You know, it might be annoying that it changes every single time, but I don't care. It's my function. It's mine. It's my game. You can do what you want. I don't care. It's, you know, because it really is yours, right? This isn't mine. And that's part of this is trying to make it a little bit unique. Okay. So I haven't called the function yet, but I have this function. So we're looping through. Okay. Let me make this smaller. I don't need it that big. Okay. So we're looping through the rows and the columns. Okay. And it's setting the X and Y position of each brick. See, what's weird to me is it's constantly setting it to 0. And that's where I don't quite understand. So size, brick width, times brick height. Okay. So it's setting to set the X and Y position of each brick. And we're also painting a brick on a canvas. Size, brick width by brick height with each iteration. The problem is that we're painting them all in one place at coordinate 0, 0. Right. Okay. I thought it was just me that I just didn't understand what the heck was going on. I'm like, okay. Anyway, so what we need to do is include some calculations that will work out the X and Y position of each brick for each loop iteration. Okay, so we were using 0, 0 as a placeholder both up here in this for function and down here. So now we're going to work on this. Okay, so every time, so now we're going to have brick constant brick X. Not sure why we're doing constant, but I'm going to go with it because it feels like that should change, right? C times brick. We'll probably move this, that's okay. Plus brick, brick padding plus brick offset left. Okay, so that's the, right, that's X, makes sense. Then we're doing constant brick Y, bricky, equals CR, row, right, okay, times, oops, row times brick height, plus brick padding, brick height. So we're saying R, the row times, okay, so we do brick height plus brick padding, okay. All right, and then we're multiplying it by the row. The R is 1, 2, 3. Okay, so like if it were 5, then it would be like 15. And then you're like, okay, well, it's 15 plus whatever. Okay. Okay, I think that's making sense to me. I could see why, you know, maybe having this, sketching this out, you know, might be a good idea, right? With some, like, dimensions and things like that, like a wireframe. Yeah, obviously. Obviously, I think if we were doing this in real, I mean, if we were doing this by ourselves, that's what we would do, right? If we were game designers, we would be sketching this out first. So let's see what's actually happening here. I'm gonna bring this down there. Oops, wow, okay. Just gonna bring this down here. All right, cool. So each brick X is worked out, multiplied by the number of the column plus the brick offset. The logic for the brick Y is identical, except it uses the row, okay, and offset top. Now, every single brick can be placed in its correct place and row with padding between each brick drawn at an offset. Okay, so now we're actually seeing, well, brick X. Okay. So instead, this is going to be, X is going to be brick X. And yeah, okay. So we're actually going to put this right in our function. Okay, so the final version of draw bricks function after assigning that values of coordinates instead of 0, 0 will look like this. Add this into your code. Add this into your code below the draw paddle. Oh, okay, so we're gonna draw the bricks after, which is good because that means I can have my ball color. Important stuff. No. Okay, so now, so this I'm, okay, defining, placement for bricks. Okay, so here we have this. We're going to move this up here, cut it, and then I'm going to put it up here. And then, obviously, this is no longer going to be that. X is going to be brick X. That's why we call it brick X. Brick X, and the Y is going to be brick Y. Okay, cool. And then obviously we're not doing 0, 0 because that doesn't make any sense. We're saying brick X and brick Y. Perfect. Okay. All right, cool. So then begin path, rectangle. Oh, yeah, okay. Good, good. Fill style, fill, close path, boom. And then we're putting all of this Okay, I'm just looking at this. So this is making, okay, so this constant bricks up here is making the array. And then once we have an array, bricks, right, C and R, columns and rows, then we go down here to the draw bricks, and it takes the C, okay, this same C, puts it in there, then this one, yeah, see, yeah, I don't know why they were declaring these as constants. These should not be constants. These should be variables. I don't get that. In the code, they wind up changing it to var. I'm changing it to let. Because these can change. I mean, we could make these change. We could make them and then also let. We're not, yeah, I'm not sure. So they have all of this. And then, okay, so they have draw bricks after. I'm going to take all this, draw bricks. Paddle. Put it after draw paddle. I'm going to format my document real quick. There we go. That makes me feel better. Okay. And then let's see. So their event listeners and the key handlers, all of that, interestingly, is before, is that they have it up at the beginning. And I wonder if that's a thing. If that's just something that you would do. I don't know. I feel like we should draw first and then listen for events, but I guess it really doesn't matter. Okay, well, let's check this out. Let's see. I still have this thing open. Let's look and see. Did I break it? Okay. Well, we haven't called it. We haven't called. Yeah, here it is. Like, we haven't called the function, right? Draw ball. So add draw bricks right before draw ball. Let's see. Draw bricks before draw ball. Draw bricks. Draw brick. Draw ball. Okay, so we're going to draw the ball. We're going to draw bricks. Okay, cool. And this is obviously in our draw. Okay, so we do draw paddle, draw bricks, draw the ball, do all the things, and the function, remember, is this draw. So this is how often this function, look at that. Yay. Cool. Okay, yeah, I failed. So, obviously, it's going right through. We haven't done collisions yet. And that's fine. That's fine. Okay, we're going to do that. So, whew, that's going to be so interesting. Yeah, very interesting. So it's interesting the physics of this. You know, is it based on where the ball hits, right? Because we have that as the ball is hitting, it reverses the Y and the X position, right? Yeah. Okay, cool. So we're gonna see next, obviously, we gotta figure out how to break these bricks. Okay. Dun, 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 dun. Let's do it. Let's do it. Oh, yeah. Collision. More collision detection. So we did the collision detection with the walls, right? So now we have to do it with our bricks. Okay, so, you know, the ball's just like going through these bricks. It's nice. So it's our decision how to implement the actual breaking of the bricks, but it can be tough to calculate whether the ball is touching the rectangle or not because there are new helper functions in Canvas for this. For the sake of this tutorial, we will do it the easiest way possible. We'll check if the center of the ball is colliding with any of the given bricks. This won't give a perfect result every time. And obviously, I mean, it's going to. There's so much more sophisticated ways to do collision detection, but we're just teaching the basic, right? So you could go all day. I could go off on this all day, all week. It would be awesome. And, you know, we don't have time for that because we got like a week left, right? This is our final. Okay, so a collision detection function to kick this all off. We want to create it. Okay, so we're dealing with the ball's coordinates now. Okay, and the ball coordinate has to do with where. Okay. So we're kind of, okay, so it's the same thing that we had. B. Okay. Okay. Let's see. We're going to loop through all the bricks and compare every single brick's position with the ball's coordinates as each frame is drawn. For better readability, we will define the B variable for storing the brick object in every loop of the collision detection. Okay, so let's go up to, okay, we've got, where's our collision stuff? Okay, we got this. Collision, collision, collision. Where's the one where, let's see, it bounces off? No? Okay. Where is it? If, else if. Here it is, the game over. Okay. Here's the one where it's like, hey, if it bounces, that's great. Draw ball. Draw bricks. So it's probably going to be in here somewhere. Draw bricks, and then it'll be our collision detection. Okay, so I feel like collision detection should probably go between the drawing and the draw, the function draw and the, you know, because we're still drawing, we're just like kind of erasing, right? Well, we're colliding at this point. We're not actually making it erase. That'll be a totally other interesting thing to do. Okay. Function. Oops. Okay. Collision detection function. Okay, so we're going to do function and collision detection. Okay, now let's see, for doing the same thing. Okay, so for this we already have this right here. I'm going to take all this and the draw bricks. Okay, oh, we're probably going to put this in there, huh? Okay, good. All right, so for this one, okay, let's do one more curly brace close. Okay, great. And then during those 4 loops, we are, making a constant, and it's B, bricks, oops, equals bricks. It's the position, the column position, and the row position. Okay, so now we're going to do the calculation. So we're saying, okay, here we have this brick B. If the center of the ball is inside the coordinates of one of our bricks, we'll change the direction of the ball. Okay, so the dx, dy are going to change. For the center of the ball to be inside the brick, all 4 of the following statements need to be true. So first, the x position of the ball is greater than, okay, so I'm just going to write this down real quick as I read it. The x position of the ball, so dx, okay, is greater than the brick x, okay, and then the dx is less than the position of the brick plus its width. Right. Okay. And then, okay, dy is going to be, it's going to be greater than the y position, brick, y, and dy is going to be less than brick, y, plus brick, height. Okay, so we're still doing all of this. Now we got to put it in an if, of course. So, it's not D. Oh, D is the direction, y'all. My bad. Okay, so it's not T. Ooh, and it's not BX. Interesting. B dot X. Let's go up here. It's this right here. I see. Okay. I'm surprised we're not using that. This dot X is a bricks CR dot X. This is like a property of the object. X and Y is the canvas. Okay. So it's X. Okay. All right. Let's do it. If X is greater than B dot X and, okay, it's the same. Okay, so it's a property. Okay, and X is less than B dot X plus the brick width and Y is greater than, it has to have all of these, Y and y is less than b dot y plus brick height. Then we're changing directions. dy equals negative dy. Right, because we're never hitting it on the x, because we're not going to have that same level of awesomeness as some of the games where it goes up the sides. I don't think. Maybe. Let's see. Okay, so now I'm getting rid of this. Okay. All right. Okay. Okay. If x. Okay. Let's figure this out. Let's keep going. Okay, so we have collision detection. This is just talking about, let's see, we need one more. Okay, one more curly brace. Below the key up handler. Okay, so this is below the key up handler below it. Now, I have all this at the bottom. I don't know. Let's see what's happening here. No, it's not doing anything yet. Okay, so that's not doing anything. But all of this, okay, let's see. They wanted the key handlers, they wanted all of this. The event listeners and everything like that. They wanted it above, they wanted it below, above. Okay. Okay. This is making two functions. This was the draw loop and the draw were two different. So, drawing loop 4. Let's see. Ball, paddle, bricks. All of this, I'm going to actually put something here, guys. Okay, I just want to kind of have, I'm trying to make this so that I can see, this is my random color for fun. Okay, before the drawing. All right, so these are all my listening for the keys, okay? Let's see. Format document real quick. Okay, cool. So we're listening. Okay, we're listening after that. Okay. Still not actually doing it. Let's see. Okay, collision detection is, okay, for, let's see, equals 0. Okay, so we're starting at C equals 0. And I'm going to go look over here. So C is our columns. Columns equals 0. And then we've got, there's column counts. We're adding. And then also there's R0. And we're adding. And then this B. Okay, we're doing B. No, we haven't called the collision detection. Hello. Okay, we haven't called it yet. So when is it actually happening? Let's write that down in the code. Add your block of code. But we're not. Okay, hold on. So tracking and updating the status. Okay. Yeah, we gotta do just a little bit of a paddle. Draw a paddle. I'm just gonna see, like, if I put, sorry, draw a paddle. If I pressed, can I make it work right now? Let's see. Okay, good. I just wanted to make sure that it was actually working, and it is. Okay, great. Yeah. Okay, so we called it. So now we gotta make them disappear. All right, so let's talk this through. Okay, so we've detected the collision, and that one collision has a okay, here it is. So that one collision detection, it's this. It's this. The brick itself is the column and row, right? Column and row. Okay. And then it's the width. It always starts at 0. You know, the width is from the left to the right, and then top to bottom. So we have to figure out as it hits between. Okay, as it hits between the B plus brick width. This right here. This right here. This B dot X plus brick width should be the key to making the blocks disappear. So I don't know how to make it disappear though. So it was like, you know, how do you erase something? So that'll be interesting to find out. Okay, here we go. It's drawing. Yeah, we have to like draw something. Okay, sorry. Okay. Alright, making the bricks. Here we go. The problem is that the bricks are staying where they are. We have to figure out a way to get rid of them. We can do that by adding an extra parameter to indicate whether we want to paint each brick on the screen or not. So do we want to do it? We only want to paint it on if the ball has not hit it, right? Okay. So status. Okay. To indicate whether we want, okay, so we're going to initialize the bricks. Let's add a status property to each brick object. Oh, wow. Okay, status property to objects. Okay, so we had the X and Y properties to our object. Our object was this bricks. So now somehow we're going to have, okay. Yeah. Bricks, constant bricks. Down here. I've changed it. Okay, for this. Okay, let R, okay, brick row. Okay, so now we're like, well, status of 1. Oh, guys. Oh my gosh. Okay. This is our object constructor. Oh my goodness. It took me, I told you that it would like eventually occur to me. So here, this is our object. They didn't say this. I wish they would have said this, or I would have recognized it. So we've got this two-dimensional array, right? The C and R. It's being placed in here, right? C, and then we're having the C with the R. Okay, and then we're telling it, okay, well, this C column is the X, and this Y is the R, right? Because we go in order. So now we have a status. Okay, and we're just saying status 1 because we're defining what that is. Remember how we would define it as like a name, and you know, when we were building an object, we would say, okay, username, phone number, da 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 da. So that's what we're doing here. Status of 1 to start. Okay, and now, oh, yeah, I don't do that. Okay, status of 1 to start. I always do that in my object constructing. Anyways, thank you, VS Code, for having red lines. Cool. So we're going to check it. If it's 1, we're going to draw it. If it's not, if it's 0, so it's like true, false, right? So, okay, cool. Let's check out what they're going to do. If it's 0, then it was hit by the ball. And we don't want it on the screen anymore. So we're going to update it. Draw bricks is down here. Sorry. When I'm working really hard, I get a little silly. I don't know if you guys have this. I think, you know, if I get a little silly when I'm working really hard and coding a lot, it just helps me to relax because obviously laughter helps me relax. I don't know if that does it for you. But yeah, I just get a little silly. Kind of lets off some of that anxiety of, you know, oh geez, like this is hard, you know. Yeah, it is hard. All right, so we got this draw bricks. Here we go. So somehow we're doing the status. Okay, so if the bricks, we still haven't like said how the status is found. I don't think we're gonna do that right now. So we've got for defining the placement of the bricks before that. Okay. So I need to check status as to whether we draw it or not based on the collision detection. It's got to be, right? It's got to have something to do with the collision detection. Okay. So here we're doing an if. So we're like, for this, we're saying if first, you know, check this again too. So we're like, for C, you know, for this, then we check if, you know, so there's like 3 conditions that really need to be met in order for painting to happen, in order for the drawing to happen. So, all right, so now if the bricks, C and R. Okay, so our object dot status. Okay, object property. It's so funny. Oh, I forget these things. Okay, 1. Then yeah, keep going. Then go. Then go. We don't have to put an else because it's like then do it. You know. Oh, this doesn't work. We gotta go all the way down here. And add 1 more curly brace. There we go. Okay, so it's like, if that's the case, then do it. Otherwise, it's just not even gonna happen. It's not gonna paint it. So it's not that. Okay. So it's not that it's disappearing. This is the weird part. It's that it's not being drawn again. Because remember, the function is kind of continuous. We don't see it, but it's always being drawn every 10 milliseconds. the canvas and everything on it is being painted. So we don't see that, right? But it's happening. So it's saying, it's checking every 10 milliseconds. Okay, is it still 1? Okay, if it's 1, go ahead and paint it. And if it's not, don't paint it, you know? Okay, cool. So we have to figure out that 0 thing. Tracking and updating the status. There we go. So now we got to go and, right, this is based on the collision detection. I also wanted to say here, okay, so the rest of the function, so if the status is 0, the rest of the function will, the bricks will not be, bricks will not be painted. Okay. And then we just move on. Cool. Okay. And then, groovy. All right. So now we're saying we got to go to the collision detection, but we still haven't, so annoying. Okay. So we're still not, okay. Collision detection is, sorry, I don't mean to go fast. Collision detection. So now we're putting in something for a status. So we're first saying if, okay. Yeah. If, so we're like, okay, let the be equal to bricks. Yes, yes, yes. And then if it's the status, keep going, you know, and keep going and changing directions based on where that brick is. Okay, cool. All right, so if, status, all right. If, put my parentheses, b dot status, because we have this, great, we don't have to write it out again. B dot status equals 1, then go ahead, keep going. Okay, keep going. Put the sound at the end. Okay, right here. Okay, cool. Keep going. All right. Okay. Keep going. If not, all right. So if not, what is it going to do? Let me just, okay, all this. I think I'm going to format the document. Sorry. Sometimes I forget that I'm recording a video. All right. I don't actually always talk to myself when I code, although it makes it look like I really do. But I don't. Okay. So one of the methods of teaching is actually talk through. So so you actually learn more, which is interesting. You learn more from somebody making mistakes and talking through their mistakes rather than somebody who's just like, they practice it forever, you watch a tutorial and they just know everything. It's not actually helping you learn the ins and outs, it's just helping you to replicate. And so if you go along with me, and in this tutorial, we're doing it the first time together, so it's a special thing. Whereas, like, if I had been doing this for a long time, I wouldn't explain as much because I wouldn't be making these mistakes and I wouldn't be figuring it out with you. So, anyways, that is just a random knowing thing. Okay, here it is. Oh, yeah. Okay, here it is. So we're like, okay, if the status is 1, so it's been painted. This is the brick. Here is the brick. We're going to go ahead and check this. Because if this is true, if this all calculates as something, one of these is true. Well, all of these statements is true. My bad. This is the and. If all of these statements are true, then we're changing the direction. But because we're changing that direction in the collision, we have to change the status to 0 because that particular brick is no longer there. And that status equals 0. But obviously I can't just do status. Let's be because it's a property of the object. Okay, cool. So basically what that's done, let's check that out. So, like, I'm trying to think about where this is being stored, right? So we've got this let be bricks. Okay, so this is going to be checked. So this particular brick, it has this one thing, and right now this particular brick in this object is there. And then it's going through and it's saying, okay, has, right, this X and Y, if we remind ourselves, this is not making it move. Let's see. This is the campus. This is the X and Y. This is the ball. Oh my gosh. See, this is why comments are so important, because I didn't put very specific comments about the ball. This is the position of the ball. Oh, jeez. Okay. This is the position, the starting position of the ball, right? Yeah. Okay, the starting position of the ball. So we're saying like this X, Y. Okay, so we have this X, that starting position, because it hasn't changed yet, right? Yeah. Because it doesn't matter, because this hasn't been called yet, so it gets called way down here, this collision detection. Okay, cool. So we draw the paddle, and then the collision detection. Okay, clear the rectangle, right? We have to make it, and then draw the paddle. Check for the collision, which is basically just saying, okay, is the ball, it won't be. The ball won't be, because the ball initial is like 0, 0. I mean the bricks, right? So yeah, it's not going to be the same. So we keep going. Okay, paddle, paddle. Now we're drawing the bricks after we check the collision. Right, because we have to, the collision detection is giving the status. The status will tell the function draw bricks what it has to draw. Okay, and then based on what that's being drawn and the paddle, then we have the draw ball, because the draw ball is dependent upon the draw bricks, which is dependent upon the collision detection, because the direction of the ball, right? Okay, cool. And then it's changing the movement. Woo! Wow. Okay, cool. Let's go back up. All right, and then it's 0. It's not going to draw that particular brick. Okay, I activated it. Let's see. Oh my gosh, I'm excited. Is it working? Boom! Oh my goodness, you guys, it's so cool. Yay. Oh, interesting. So it only changes now when, let's see, when it hits a wall. Oh, look at that. Ooh, cool. Okay, hold on. So it did, this is cool. Okay. So it's still not going to end once our, right, like once the bricks are drawn. Cool. Okay, so we didn't, because we didn't define that it had to be either top or bottom. It's just changing direction. So I have all the bricks, right? We should, we're going to have a message that says, congratulations. And then restarts the game. And then, we could have an increment of like, oh, you want to go faster? Next level, And the bricks are a different shape and all that good stuff. Okay. Cool. We did it. All right. Definitely getting there. We're going to track the score and win. Oh, we're going to have a score too. I love that. All right, let's do that. All right, guys. So we're destroying bricks. Yay. Now let's make a score. Let's have a score. So this is kind of easy. I mean, this is easy compared to what we've been doing. We're going to make a score. Okay, it's going to be after. First, up in my variables, up in this variable area, I'm going to put it after here, and I'm going to keeping score variable. Let score equal 0, right? It's always going to start, and we're going to have to reset it at the end of the game and all that good stuff. So right after we've detected everything, bloop, 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 because when it's 0, if everything is 0, we're going to have to say something like, if there's no more bricks, right? If there's no more bricks, then stop. Okay, cool. So we're going to have this function, draw score, and okay, so CTX font. This is on the canvas. Okay, cool. Okay, this is an interesting way of drawing font. So I haven't done this yet. So 16 pixels, Arial. Okay, fine. I'm doing sans serif, y'all. Okay, the CTX font. And then CTX fill style equals ball color. I don't know if I could do the ball color. Let's see. CTX. I'm obsessed with my random everything changing colors. All right. Fill text. Okay, we're doing the concise method of concatenating. Score. And then I suppose, yeah, this is the placement. So 8. Okay, so 8 over 20 down. Over 8, 20 down. I think that's a weird place for the score, but now I forget how big our canvas is. Okay. Oops. 8, 20. Okay, great. Fill text. Interesting. So it's like our fill text is actually writing text. Cool. Okay. Drawing text on a canvas is similar to drawing a shape. The font looks exactly like the one in CSS. We haven't done it yet. Let's see. Draw score. Let's just put it in here real quick. Draw ball should be after collision detection. I don't know. We might change this, but I'm assuming that it should be that. Yeah. Oh, there it is. Score 0. Okay, cool. Great. Okay, obviously it's not doing anything. So I have to make the score plus every time the collision detection is true, right? So when the status is, every time the status is 0? Is that when the score goes up? Let's see. Every time, I think. Okay, let's find out. To award a score. Yeah, in collision detection, sure. We might draw the score in the collision detection. Okay, so in the collision detection, Yeah. Oh, I was right. Yay. So every time the brick status is 0, our score goes up. Score plus plus. Remember, score plus plus is the same as saying like score plus 1. Okay? It's like score equals score plus 1. That's what score plus plus means. Calling draw score keeps the score up to date at the following inside just below the draw paddle. Does it matter? Let's see. 1. All right, so I took out a huge chunk of the video where I was trying to figure out if it mattered for a draw score to be before or above, above or after collision detection. And I'm just going to put draw score where they say draw score is supposed to go. So once, right, we had game over, right? And now score plus plus, and then if the score equals the brick row count times the brick column count, then we're going to say the reload, the clear interval, all that good stuff. So the end of game, the same end of game thing that was down here, we're basically doing the same thing except we're putting it in the collision detection, because once the collision detection detects 0 more bricks, then we need to be done. Okay, so let's go up here, score plus plus, and then an if statement, a new if statement, which says if the score is the same as 3 zeros brick row count times brick row height, brick column, oh my bad, brick row count, brick column count, then we won, right? Alert. Congratulations. You win. Okay, and then we're doing this. That's the first line of code. And then the next line of code, we're reloading. Document dot location reload. And that's basically after you say okay. All right, and then clear interval. And that is the needed for Chrome. Okay. Same as the other, same as the end game, right? Okay, do I have enough? Do I have enough? Yes. Your users can actually win the game when they destroy all the bricks, which is quite important when it comes to games, right? Okay. Document dot location dot reload function reloads the page and starts the game once the alert button is clicked. Okay, so we're going to have mouse controls next. All right. Go ahead and try yours out. I'm going to have to make mine slower, apparently, because I'm just not doing very well today with actually finishing this game. So let's make sure it works. I didn't want to show you if I had any failed attempts, so I paused the video, but here we go. Yay, congratulations. I won. Okay, let's move on. We're going to do mouse controls next. This is so cool. We're almost done. We're going to do new event listeners. We're talking about our mouse, which is cool, so that we don't just have to rely on the keyboard. We can also do mouse. Okay, let's go back up to the top where our event listeners are. We're going to do some other things. Mouse move. Cool. It's a mouse move event. All right. So, probably going to do it, let's see, just below the key up. Okay, so now instead of, we're going to have listening for mouse movement. Okay. So document dot add event. Oops. Event listener. So now our event is mouse move. Cool. Okay, we got all these cool little events already programmed in. Part of our standard JavaScript library. Built-in function, false. Okay, so we're starting with the false, of course. All right, so the mouse move is not moving to start with. That's the same way we did the others. Okay, so now we're anchoring the paddle movement to the mouse movement. Oh, we can update the paddle position based on the pointer coordinates. The following handler function will do exactly that. Add the following function to your code below the previous line you added. All right, so now we are anchoring paddle movement to the mouse movement. And it only, since it's only left and right, we only do on the x-axis, right? Okay, so function mouse move handler, which is this function that's going to happen. Mouse move handler E. Oops. E. Oops. Wow. Okay, here we go. There we go. Function mouse move handler input E. Constant relative x. E dot client x minus canvas dot offset left property. Okay, it's a property of, it's a property of the HTML element offset left. Okay, if relative x is greater than 0 and relative x is less than canvas dot width, then paddle x equals relative x. Relative x. E dot client x. So is that where our client x is going to be? Is this a built-in function, built-in property? Maybe. Okay. Parameter. E is a parameter. And E, right, is the parameter of this, client x. Okay, we probably have to define this. So in this function, we first work out of a relative x value, which is equal to the horizontal mouse position in the viewport, which is the same as E.client x minus the distance between the left edge of the canvas and the left edge of the viewport. Okay, so basically, like, if your mouse is way over here, it's going to stay on this canvas. Okay. All right, if the relative x pointer position is greater than 0 and lower than the canvas width, the pointer is within the canvas boundaries. The paddle x position, which is anchored on the left edge of the paddle, is set to the relative x value minus half the width, so it's middle. Okay, so it's actually relative to the middle of the paddle. The paddle will now follow the position of the mouse cursor, but since we're restricting the movement to the size of the canvas, it won't disappear completely off of either side. Okay. Oh, it's broken. Look at that, it's broken. What? Oh no. It's this right here. Something's wrong. Right? This is what I'm thinking. Something's wrong because see how key handler, this is supposed to be a function. Why, you know, when I hover over here, I see it. What did I? Oh, look. So funny. I had to do that MOUSE mouse move hand. I had move handler. Wow. I did not even see that. I bet you guys did. Okay, or not. I don't know. But let's see. Did it not break? Is it unbroken now? Oh, okay. Look. What happens? Oh. Okay. Ooh. No. Okay, cool. Okay, so now I'm moving my mouse and that's groovy. Alright, cool. Okay, so that works. That was easy. That was super easy. So interesting. But it's using some weird things that, that I didn't really know were functions, right? We're defining this relative x. We have this client x. So client x is a property of a mouse move, looks like. Yep, interesting. Okay. Cool. So, yeah. All right, we'll think about that. Okay, cool. We're good. Now we've got a complete game. We're going to just do some quick tweaks, it looks like. Okay. Wow. Good job, guys. We did it. I hope you're still with me here. Finishing up. Next. Okay, this is the 10th and final step. All right, this is going to be exciting. Obviously, we can always improve. Like, I want to go off on colors and change stuff, and I want to, maybe there's lots of stuff that I would do personally with this game. Maybe like an interesting background. I don't know. I think there's ones, right? Don't they have some of these brick-breaking games where it's like uncovering a picture or something? So giving the player some lives. All right. Okay, cool. So, like, sorry, you can't, you can keep going. Ooh, interesting. So drawing the life counter looks almost the same as drawing. So we're going to give them some lives. Give our players some lives. Okay, let lives equal 3. Start with that. Drawing the life counter looks almost the same as drawing the score counter. Add the following function below the draw score. So it's kind of like, okay, makes sense. We're just doing the same thing. Draw. Let's go down to our draw score. Okay. Let's do the same thing. I'm just going to copy this sucker here. And I'll just change some stuff in there. Instead of draw score, obviously, I'm going to draw lives. And we'll keep it 16. We'll do ball color still because that's the kind of person that I am. And lives is going to be the lives, and it has to be something different, right? Oh, so now we're using a calculation. Canvas with minus 65. Oh, it's going to be canvas with minus 65 and then down 20. Okay, so it's going to be on the other side. I get it. All right. $20 was the same. Okay, cool. So let's see. Do we have it? No, we haven't called it. Hello. All right, let's draw our lives after we draw our draw. In our draw function, draw score, draw lives. Perfect. Okay, there we go. So it doesn't do anything. It'll just stay there forever, like nothing happens. It says game over. Well, don't do game over. So now we're going to go down here and we're going to say, no, don't do game over yet. Okay, so first, okay. So we're only going to say game over, else, okay. It's going to be an else if, then it's probably going to be like, okay, so it'll probably be something like else if lives zero, then game over, right? So there has to be a count to deducting. Okay, so collision, you got this collision detection. It's going to be inside collision detection, right? Let's see. Because collision detection. Okay, so then you're like, if congratulations, you win. All right, so we've got this is saying if the score, if all of this happens. Zero. Okay. My brain's not working very well. Let's keep going. We can also reset the ball and the paddle positions when the player begins their next life. Okay, instead of ending the game will decrease the number of lives. Okay, so alert, game over. So we're actually replacing we're saying else, okay, lives minus makes sense. Okay, so we're saying lives minus 1, and then if there's no more lives, then we do alert. Okay. Then it's else. It's resetting. Right. Okay. So it has to reset. See, this is kind of a pain in the butt because it has to be like the initial value. You know? That's interesting. Okay. Because it's like it has to go back to the initial value, but somehow the initial value has to change. And then it has to be able to go back to that initial value if okay. I guess you could have these. Well, I mean, it's always going to be this. I'm sorry. I'm trying to think, like, are you always going to have the height and the width the same? Yeah, it's always going to have the same starting point, so you don't have to worry about these numbers. I was just thinking too much on that one. Okay, so sorry. I was thinking that we needed to worry about that. We don't. So we're just resetting back to the initial. Okay, -2 dx dy, and then we have paddle x equals, oops, okay, let's start width minus paddle width divided by 2. All right. Now it's subtracting 1 life. There are no lives left. Okay, rendering. I did this. Improving. Rendering with request animation frame. Okay, hold on. Let's check that out. So oh, it automatically starts. Oh, wow, look at that. That was fancy. Okay. Nice. Congratulations. I win. I still have 2 lives. Let's see what happens. I mean, I would probably wanted to see something like, you lost a life, right? Yeah. I don't want it to. Game over. Okay, perfect. All right, cool. I mean, there are so many other things we could do with that. Let's work on something that's not connected to the game mechanics, but to the way it's being rendered. Okay, so, yeah, because it's kind of like, it's a little glitchy. I don't know. It's a little slow. Let's see what happens. Replace the following line with draw. What? Okay, and remove each instance. Then at the very bottom. Interesting. Okay, so bloop. We are getting rid of this. Oh my goodness. Okay, so in step 10, we remove this in place of having request animation frame, a better way of rendering in the browser. All right, cool. And then I also have to get rid of, well, first of all I'm doing is calling the function after removing the above line. We simply call the draw function. Okay. Remove each instance. Command F. Clear interval. We want all this gone. Okay. This whole thing. Bloop. Okay, and let's go find it. Clear interval here. There's just 2 of them. Okay. Then at the very bottom. After the draw. Dun, 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 dun. This draw function is so huge, right? Alright, at the very end of it, so up above line 225. It says that, okay, so request, ooh, we're not doing that. Remove, oh, interesting. Request animation frame. Oh, interesting. So now, okay, so the draw function is now, instead of the fixed 10 milliseconds frame rate, we're giving control of the frame rate back to the browser. It'll sync the frame rate accordingly and render the shapes only when needed. This produces a more efficient, smoother loop than the older set interval method. Ooh, okay. But does that mean it's going to be faster? No. Like, it's just the browser says so. Oh, you guys, we did it. I hope that you are still with me and you have not given up. If you have not and you have a working game, congratulations. That's awesome. I feel like, you know, we are not experts in JavaScript yet, but hopefully you can understand some of these different methods and properties, and you can recognize, you know, the variables and what's happening. You can kind of recognize patterns and understand what some of the things are happening inside the code. You know, that's what Introduction to JavaScript is really an introduction to JavaScript, because this is something that you will take years to become an expert in, unless you were to just like never sleep and only study JavaScript. That's probably a bad idea. So, good job, congratulations, and thank you so much for being with me for this class. I hope it was good. I know it was fast.